to all. Welcome to Daffodils Concept School and Pre-University College. PU Second Year Physics. Chapter name Dual Nature of Radiation and Matter. Today's class number is 10. Today's topic Numericals on de Broglie wavelength. Before solving the numericals, just all of you recollect the formula. Already I have explained all these things. The first one is de Broglie wavelength of a particle, that is given by lambda is equals to h by p, where h is Planck's constant, p is momentum. Now h value is, that is Planck's constant value is 6.63 into 10 to the power minus 34 joule second, and p is nothing but product of mass and velocity, that is m is the mass, v is the velocity. If you substitute all those values, you can calculate the de Broglie wavelength of a particle. Next one, that is expression for the de Broglie wavelength of a photon. Lambda is equals to h divided by mc. H is Planck's constant, m is mass of the photon, c is speed of the light. Here if you substitute all these values, you can calculate the de Broglie wavelength of the photon. Next, that is de Broglie wavelength in terms of kinetic energy of the particle, that is lambda is equals to what? H divided by square root of 2m ek. Here h is Planck's constant, m is mass of the particle, ek is kinetic energy. Already I have explained how we got this formula. You can observe here kinetic energy is equals to p square by 2m. From this one we have taken p square is equals to 2m ek. From this one p is equals to square root of 2m ek. Ek is nothing but here kinetic energy, and lambda is equals to h divided by p. In place of p, if you substitute this equation, we will get lambda is equals to h divided by square root of 2m ek, where h is what? Planck's constant. H is what? Planck's constant. M is what? Mass of the particle. Ek is what? Kinetic energy. By using this equation, we can calculate the de Broglie wavelength in terms of the kinetic energy of the particle. Next equation, that is de Broglie wavelength in terms of the accelerating potential, means that when they have given the accelerating potential, if they have given the potential difference, if you want to calculate the de Broglie wavelength, we have to use this equation. Lambda is equals to h divided by square root of 2m qv, that is here m is mass of the particle, q is charge on the particle, v is accelerating potential, h is Planck's constant, lambda is de Broglie wavelength. Here v is equals to, that is a potential difference or potential is equals to work done divided by charge. Here in place of work done, we have substituted the kinetic energy. From this one we got kinetic energy is equals to v into q. In the previous one we got lambda is equals to h divided by square root of 2m ek. Here in place of ke, that is in place of kinetic energy, we have substituted q into v. Just remember this formula only, that is lambda is equals to h divided by square root of 2m qv. Next one, that is expression for de Broglie wavelength in terms of the accelerating potential for an electron, that is lambda is equals to h divided by square root of 2m qv. In place of q, what we have to substitute? That is e. This equation is similar to that of the previous one. Here in place of q, we have substituted the e. Why? Because in the previous equation they have given particle, but here they clearly mentioned the electron, so that we have to take that one as the charge on the electron. M is mass of the electron, E is charge on the electron, V is accelerating potential, H is a Planck's constant, lambda is a de Broglie wavelength. Now by using all this formula, we are going to solve the numerical questions. Now all of you read the given question, that is question number 8. What they have given? Calculate the momentum, that is A is momentum, B speed And C. de Broglie wavelength of an electron with a kinetic energy of 120 electron volt. An electron is there which is having a kinetic energy that is equals to 120 electron volt. Now we have to calculate the first one. A is momentum, next B is speed, next C is de Broglie wavelength. Now write the kinetic energy whatever they have given. Kinetic energy is equals to what? 120 electron volt, that is 120 into 1.6 into 10 to the power minus 19. If you multiply 120 into 1.6, then you will get 192 into 10 to the power minus 19 joule. Here if you want to convert the value from electron volt to joule, we have to multiply with a value of 1.6 into 10 to the power minus 19. So that we got kinetic energy is equals to 192 into 10 to the power minus 19 joule. Now what we have to calculate? Momentum. We know that the basic equation for the kinetic energy, that is kinetic energy is equals to p square by 2m. P is what? Momentum. M is what? Mass of the particle. K is what? Kinetic energy. From this one, just make the expression for the momentum, that is for the p. Here p square is there. If you take this 2m LHS, what it will be? 2m into Ek. From this one, here p square is there, but we have to calculate the p value. If you take this 2, or as the value which is in the power is nothing but here 2. If you take this square LHS, that will be what? Square root. So that p is equals to square root of 2m Ek. Now substitute the mass of the electron. Substitute the kinetic energy of the electron. Here now p is equals to what? P is equals to square root of 2m Ek. 2 as it is, m, that is the mass of the electron, 9.1 into 10 to the power minus 31. Kinetic energy 192 into 10 to the power minus 19. Now multiply the 2 into 9.1 into 192. You will get nearly 3494.4 into, add the powers, 10 to the power minus 31 and minus 19. What it will be? 10 to the power minus 50. That is, you will get square root of 3494.4 into 10 to the power minus 50. Now separate this term, that is whatever the square root of some value is there, separate this one, that it will be square root of 3494.4 into square root of 10 to the power minus 50. If you calculate the square root of 3494.4, you will get nearly 59.11 into square root means in the power you can write a 10 to the power, that is 1 by 2. In place of square root you can write that is nothing but 1 by 2. 10 to the power minus 50 as it is. In place of square root, what we have written? 1 by 2. Already we know the formula and we have used in the last numericals what we have solved. Here you can observe that x power m whole to the power n. X power m whole to the power n is equals to what? X to the power m into n. Here 59.11 as it is, write that one. Here I have written 59.11 into, use that formula, x to the power m whole to the power n is equals to what? X to the power m into n, that is 10 to the power minus 50 whole to the power 1 by 2 is equals to 10 to the power minus 50 into 1 by 2. That is, multiply that one, you will get, that is 10 to the power minus 25. The momentum of the electron is given by what? That is P is equals to 59.11 into 10 to the power minus 25 kg meter per second. Next we have to calculate the speed of an electron. When you know the momentum, it is easy to calculate the speed. Why? Because P is equals to m into V. Here m is the mass of the electron, P is already we have calculated that one, so that we can make P is equals to mv. From this one, V is equals to what? P divided by m. Here substitute the P value, that is momentum value, and mass of the electron, whatever the value is there. Later simplify that one. P value here I have written, that is 59.11 11 into 10 to the power minus 25 divided by m is what here? Mass of the electron, that is 9.1 into 10 to the power minus 31. Next 59.11 divided by 9.1, you will get 6.49 into 10 to the power minus 25. Take this denominator term, that the one which is in the denominator, that is nothing but 10 to the power minus 31. 10 to the power minus 31 is there in the denominator. Take this one to the numerator. What it will be? 10 to the power plus 31. Next here 6.49 as it is into 10 to the power minus 25 plus 31 x to the power m into x to the power n, that is equals to x to the power m plus n. 6.49 into 10 to the power minus 25 plus 31. What is the value? 10 to the power 6. We got the speed of the electron. Next, we have to calculate the C, that is de Broglie wavelength. Lambda is equals to h by p, that is the basic equation for the de Broglie wavelength. Substitute the h value, that is a Planck's constant. Later p momentum value. H value is what? 6.63 into 10 to the power minus 34. P value 59.11 into 10 to the power minus 25. Already we have calculated in the part A. Now substitute those two value, already we have substituted. Now simplify the numerator and denominator term, that is 6.63 divided by 59.11, that we got 0.1121 into, in the numerator 10 to the power minus 34 is there. In the denominator, whatever the value, whatever the power term is there, take that one to the numerator. It will be 10 to the power plus 25. Now simplify that one. 0.1121 into 10 to the power minus 34 plus 25. What you will get? 0.1121 into 10 to the power minus 9, that is minus 34 plus 25. You will get a 10 to the power minus 9. That is here I have written 0.1121 into 10 to the power minus 9 meter, or as 10 to the power minus 9 is nothing but the prefix which is used to indicate that 10 to the power minus 9 is nothing but nanometer as it is. So that lambda is equals to, we got 0.1121 nanometer. In this numerical we have calculated the, initially we have calculated the momentum by using the kinetic energy relation. A is over, we got certain value, that is momentum is equals to 59.11 into 10 to the power minus 25. Later speed of the electron. Yes, by using the basic equation of the momentum we have calculated the speed. Later de Broglie wavelength, that is lambda. Lambda is equals to h by p. By using this one we have calculated the lambda value. Next we will move to the next numerical question, that is question number 9. Okay, now all of you read the question number 9. Calculate the momentum and de Broglie wavelength of the electrons accelerated through a potential difference of 56 volt. Here we have to follow the same method whatever we have followed in the previous numerical. In the previous numerical they have given the kinetic energy. You can observe that question. Here what they have given? They have given the kinetic energy. But in this question what they have given? Potential difference, that is the difference between the previous question number 8 and the question number 9. So that we have to follow the same method only, but in that question they have given the kinetic energy, but in this question they have given the potential difference. Now first we have to calculate the momentum. Next we have to calculate the de Broglie wavelength. Again same formula we are going to use here, that is kinetic energy is equals to p square by 2m. What we have to calculate? P, momentum. But here have they given the kinetic energy value? No. So that what we have to do? We have to convert the equation in terms of what? Kinetic energy. We know that potential is equals to work done divided by charge. From this one, in place of work done, what we have to substitute? Kinetic energy. In place of Q, what we have to substitute? E. Now kinetic energy is equals to, take this E, LHS, what it will be? V into potential into charge on the electron. Now substitute in place of EK, what we have to substitute? V into E. V is what? Potential. E is what? Charge on the electron. Is equals to p square by 2m. What we have to calculate? Momentum. That is, we have to convert the equation relating with the momentum. That is, p square is equals to 2mv into e. Now p is equals to, if you take this square LHS, what it will be? Square root. That is, p is equals to square root of 2mve. Now in the next step, we are going to substitute the value of the mass of the electron, accelerating potential, next charge on the electron, square root as it is 2 into mass of the electron. What is the mass of the electron? 9.1 into 10 to the power minus 31. Next into V is what? Potential. Have they given the potential difference? Yes, they have given. That is nearly equals to 56 volt. You should remember this one. To indicate the potential, we will use the same symbol. SI unit of potential also volt. To indicate the volt, that is VOLT. To indicate the volt, we will use the same symbol, that is V. Potential is indicated by V. Its SI unit is volt. That is also indicated by V. So that no need to get confusion. Next. Now simplify the next thing, that is 2 into 9.1 into 56 into 1.6. If you multiply this term, you will get nearly 1630.72. Next into add these two powers, minus 31 and minus 19, that is you will get 10 to the power minus 50. Next split the term and take the square root of the 1630.72. You will get nearly 40.38 into square root of 10 to the power minus 50. Square root of 10 to the power minus 50 can be written as 10 to the power minus 50 whole to the power 1 by 2. 40.38 as it is. What you will get? X to the power m whole to the power n is equals to what? X to the power m into n. M into n means here 10 to the power minus 50 into 1 by 2. What you will get? 10 to the power minus 25. We have followed the same thing in the previous numerical, whatever the method we have followed. We have calculated the momentum here. Next we are going to calculate the B, that is de Broglie wavelength. If you calculate the momentum, then we can calculate the de Broglie wavelength just within 2 or 3 steps. That is lambda is equals to, that is de Broglie wavelength is equals to what? H divided by P. H is what? Planck's constant. H is what? Planck's constant. P is what? Momentum. Substitute the momentum value, that is 40.38 into 10 to the power minus 25. Here H value we have substituted, that is 6.63 into 10 to the power minus 34. Next simplify this term, that is 6.63 divided by 40.38. What you will get? 0.1642 into 10 to the power minus 35, and take this denominator power to the numerator. What it will be? 10 to the power 25 minus 34 plus 25. You will get, that is 10 to the power minus 34 plus 25. Here use the formula x to the power m into x to the power n is equals to what? X to the power m plus n. 0.1642 into 10 to the power minus 34 plus 25. If you add these two, what you will get? 10 to the power minus 9. Your de Broglie wavelength answer is, that is lambda is equals to 0.1642 into 10 to the power minus 9 meter, or else we can make that one as 0.1642 nanometer. Nano is the prefix used to indicate the power, that is 10 to the power minus 9. Here in this numerical we have calculated the momentum as well as next de Broglie wavelength. Next we will move to the next question number, that is 10. Now all of you read the question number 10. An electron and photon each have wavelength of 1.00 nanometer. Find, what you have to calculate? A, their momenta, means that momentum of the electron as well as momentum of the photon. Next B, the energy of the photon. Next what we have to calculate? Energy of the photon. Next C, the kinetic energy of the photon. Write the value whatever they have given, that is wavelength of an electron, that is lambda E, that is 1 nanometer. Here I have written that one in terms of the SI unit, that is 1 into 10 to the power minus 9. Nano is equals to what? 10 to the power minus 9. Next they have given momentum of the photon. Here in the question itself only they have given an electron and photon each have a wavelength of 1 nanometer, means that electron wavelength and wavelength of the photon both are same only, there is no difference. I have written this one only. Wavelength of a photon is equals to 1 nanometer, or that is nothing but 1 into 10 to the power minus 9 meter. Next, we are going to calculate the that is their momentum. Their momentum means we have to calculate the momentum of the electron as well as momentum of the photon. First, we are going to calculate the momentum of the electron. Momentum of the electron is given by, that is, first we know the basic equation. What is that one? Lambda is equals to h by p. What you have to calculate? P is equals to what? It will be h divided by lambda. So that here I have written PE is equals to what I have written? H divided by lambda. Lambda E means wavelength of the electron. PE means momentum of the electron. Now here momentum of the electron, just observe here, momentum of the electron is equals to, what is this one? Planck's constant. Substitute the value, that is 6.63 into 10 to the power minus 34. Next, lambda E is what? Wavelength of the electron, that is 1 into 10 to the power minus 9, that is equals to 6.63 divided by 1. What we will get? 6.63 only into 10 to the power minus 34. In the denominator 10 to the power minus 9 is there. Take this one to the numerator. What it will be? 10 to the power 9. Here x to the power m into x to the power n is equals to x to the power m plus n. That is 6.63 into 10 to the power minus 34 plus 9. You will get 6.63 into 10 to the power minus 25 kg meter per second. Now we got the momentum of the electron. Next, what we have to calculate? Momentum of the photon. Momentum of the photon, that is P, is equals to h divided by lambda photon. Here lambda photon and h value we have substituted and simplified in the same process, and we will get the same value. Why? Because lambda photon and lambda electron both are same, as well as in the numerator Planck's constant is there, so that we will get the same answer what we got in the previous one, that is momentum of the electron. Momentum of the photon is equals to 6.63 into 10 to the power minus 25. Momentum of the electron is also equals to 6.63 into 10 to the power minus 25. Now A is over. Next, what we have to calculate? We have to calculate the energy of the photon. What we have to calculate? Energy of the photon B. Next, here energy of the photon is given by E is equals to what? Hc by lambda. Substitute the value of Hc lambda. H value, that is 6.63 into 10 to the power minus 34. C, 3 into 10 to the power 8. Lambda, that is 1 into 10 to the power minus 9, that is wavelength of the photon. 6.63 into 3, that is 19.89. 10 to the power minus 34 into 10 to the power 8. If you take this denominator 10 to the power minus 9 to the numerator, what it will be? 10 to the power plus 9. Now, bases are same, means we have to add all the powers, so that 10 to the power minus 34 plus 8 plus 9, 19.89 into 10 to the power minus 17. This is the that is energy of a photon. Energy of the photon we have calculated. Next, C. In C, what we have to calculate? Kinetic energy of the electron. Kinetic energy of the electron, again we are going to use the same formula, that is B square by 2m. But here what we have to calculate? Kinetic energy. Whether you got the momentum value? Yes, you can observe in the previous page. Here we got the momentum value. What is the momentum value? 6.63 into 10 to the power minus 25. That is momentum of the electron is equals to, that is also same, that is 6.63 into 10 to the power minus 25. Here what we have to calculate? That is kinetic energy of the electron. Then what we have to substitute? Momentum of the electron. kinetic energy of the electron, that is equals to p square by 2m. P is, that is the momentum of the electron, 6.63 into 10 to the power minus 25 divided by 2 into mass of the electron. What is the mass of the electron? 9.1 into 10 to the power minus 31. Now we are going to simplify this one. 6.63 whole square into 10 to the power minus 25 whole to the power 2. Next, in the next step, 6.63 whole square, calculate this one, you will get 43.957. Next, what we have to do? Again, use the formula x to the power m whole to the power n is equals to x to the power m into n, that is 10 to the power minus 25 whole to the power 2, that is equals to 10 to the power minus 50. Okay, in the denominator, 2 into here, what you have to write? I think you have to make one more step here in the denominator. You please mention 2 into 9.1, that is 18.2. Shall I write here? Yes, all of you make that point, that is 18.2 into 10 to the power minus 31 10 to the power minus 31. Next, that is 43.957 divided by 18.2. Calculate that one, you will get nearly 2.4152 into 10 to the power minus 50 into 10 to the power 31, that is 2.4152. If you add these two, you will get a 10 to the power minus 19. Here, up to here, we got that is we calculated the kinetic energy of the electron, that is 2.4152 into 10 to the power minus 19 joule. In this numerical, we have calculated the momentum of the electron, momentum of the photon, next energy of the photon, next kinetic energy of the electron.